today, go ahead and talk today some about the next conic section, which is the ellipse. We're going to talk about those equations and so forth. It does have a lot of the same skills we need with parabolas, and that is that completing the square, that kind of stuff. And so from that standpoint, that's good practice on what we're doing. You will get to use the gold sheets. Now, understand that the equations that I gave you on the gold sheets are written a little differently than what I've got here, but they've got the squared term, right? They've got them just flipped around, right? The squared term on the left. I didn't write the gold sheet, but I didn't think it was worth rewriting the whole thing just for that. So I don't care if the problem says write it in standard form and you flip it around like it is on the gold sheet, or you take what's on the gold sheet and flip it around so it looks like what we've been doing. Either way, right? And I would prefer, you know, kind of like I've told you before, where I've given you the sheets like this, is not to be writing other notes on there. That's not the idea. But in this case, if you did want to, you know, below that standard form of the parabola, if you wanted to rewrite it where you flipped it around, if you want to do that, that would be okay. But I'm giving you that just kind of as a guide for the formulas, but not for a whole bunch of other notes to yourself. So I think today, the thing we should focus on mostly is the whole completing the square and getting them in the right form. That's probably the more difficult part of that. So any questions? Let's start on the 10-2 side. Any questions that you want to look at all on that side? Number 4. Okay. And I would put number 1, 2, like Allie and I were talking, you know, when you start going through 1, 2, and 3, and all of a sudden you start realizing that none of those have that 1/4p part, right? They just, it turns out the 1/4p is what on those problems? Just 1, right? And it's not in there. So what happens when it does need to be in there? So if you take one like number 4, and actually number 5 is very similar to that, those are really the ones I think we want to focus on here a little bit. So on this one, what I would suggest is add the 14 over there with the y, because we know we want to complete the square here on this, and so we have something like that. But before we complete the square, what do we have to have in front of that x squared? We have to have a 1, which means what do we need to do here? Now, we could divide both sides by -2. The problem with doing that would be this right here, you get a fraction, right? So what would be another option? Take out a -2, right? Now, if you divide, that's okay, but I would reserve dividing for one. Like if this was the same exact problem and this said 2y right here, then for sure that's what I would do. I would divide everything by a 2. Because everything is divisible by 2, then I think that's a good time to do that. But if it's not, like this one or this one, then I would just take out a -2. Now, it could still work, and you would have x squared, then what? Turn to minus, right? And then we would leave a blank there because we're going to want to complete the square, right? This side would have y plus 14, and it's also going to have a blank because we're going to be needing to balance that out. Okay, well, what is going to go in our blank here? Plus 9. What needs to go over here? Be careful. -18. Okay, because what we did here is we added a 9 so we could complete the square, but because the -2 was outside there, we actually added a -18 to that side. Okay, and so we need to put a -18 to this side. So this side ends up being y minus 4. This side is -2, and then the parentheses is what? x minus 3, and now we've got it in the form we're looking for. So that's how that 1 over 4p, that's how a number gets outside those parentheses, is it's been factored out. Now, you also could get a number outside the parentheses over here. Like, for example, if there would have been a 2 in front of this y right here, we would have wanted to take out that 2 and then divide it. Matter of fact, I'm gonna do one. We're gonna do one like that here in a minute. I'm not sure you had one like that on the worksheet, so I'm going to show you what that would look like. Okay, but now we've got our center. Now, what did they want on this problem? Did they want center and all that stuff? Or not center, yeah. So vertex is 3, 4. Focus, we'll get that in a minute. Well, I guess we got an axis of symmetry we can get right away, can't we? Axis of symmetry is, this is an up and down one, right? This is an up and down one, and so it's going to be whatever your x coordinate of your vertex is, right? So x equals 3. So it's going to be x equals 3. But now we got to find p. So 1 over 4p is equal to negative 2 over 1. We cross multiply, negative 8p equals 1. P equals negative 1/8. Okay. Now, I don't worry so much about the negative on the p, other than I know, since this is negative, I know this is going to go down, right? Since it's negative, I know it's going to go down. Yes?
If you divide by negative 2 at the beginning, would that just, should you get the same answer? Or?
Yes. I tell you what, did you do that? Is that how you started it?
Yeah.
Let me do that. Oh, no, I can't. I don't want to. Who's not here?
Table.
Chloe. And yeah, that's another reason I thought about doing the quiz and around just about as many people gone here. So, yes, you should. Let's go ahead and finish this real quick. So we know this is going down. So 3, 4 is up here. It's going to go down like this. Focus is going to be down 1/8. So it's going to be at 3 and what? 3 7/8. Did I do that right? So it'll be over 3 and it'll be 1/8 down from 4. And then the directrix would be up here. It'd be 1/8 above the 4. So it'd be y equals 4 and 1/8. Right? So that kind of stuff. Okay, but let's talk about Jack's question. So Jack's question would tell us this. So let's say we had divided everything by 2 right away. So we get 1/2 y equals negative x squared plus 6x minus 7, like that. Is that what you're saying? Okay. Did you divide by negative 2?
Yeah, divided by negative.
Negative 2. Okay, so that would turn to that and that. That's not a bad idea. And we get all that. Now, did you move the 7 over here then?
Yeah.
So you get negative 1/2 y minus 7 equals x squared minus, yeah, this is fine. This is just fine to do this. Minus 6x, and then we're going to need to put something in. Okay, so what do we need? We need a plus 9, and we need a plus 9 over here, right? And I get it. That factoring out thing, you always got to remember to multiply, and that's kind of weird. And this lets you avoid that. Okay, now, so now you have negative 1/2 y plus 2 equals x minus 3 squared, correct?
Okay.
But we can't leave this way, right, because of what we see over here, right? We want a 1 in front of that also. So what do we have to do here? You got a choice. You could just take out a negative 1/2, but you're right, it might be smarter to just times by negative 2, right? Do what you need to make this a 1 right here. So multiply both sides by negative 2. So you multiply this by negative 2, you get 1y. You multiply that by negative 2, you get negative 4. You multiply the parentheses by negative 2. So you actually don't multiply anything by negative 2 other than just stick it in front. And sure enough, isn't that the same thing? I think that's the same thing we had. So you might look at that and think that's better or easier, makes more sense to you. Fine, not a problem. Okay, so, and that's what I wanted to do an example of that anyway. It's possible that even if you did the factoring out version and you had a number here, it's possible you still had a number there. Like, let me just show you let me show you a quick example. So let's say you had done factoring, or you had done the dividing thing, or whatever. And at some point, you may end up with something like this. 2y plus 6 equals, let's make it not even work nice, 5 x minus 2 squared. So you did your, let's say you're one of those people who did the factoring out thing. And so you factored out a 5, you got your completed the square, and you end up with this, right? What do you need to do now? You need to divide by 2, right? So that's fine. Just divide this side by 2, or take out a 2. Though, if you take out a 2, that's fine, but why are you taking out a 2? So you then can divide by it, right? You want it out of there. So just divide by 2 right now is fine. You get y plus 3, and then what would this side look like? It would just be 5 halves, x minus 2. You don't have to do anything with this thing. You can just divide the 5. Now you say, well, I thought you had to divide the whole side. Well, you are dividing the whole side, right? It's kind of like if I had 6 times 8, and I want to divide that whole side by 2, right? That's 6 times 8 is what, 48? If I want to divide the whole side by 2, I really only have to divide that by 2, right? Because what's 6 divided by 2? 3 times 8? 24. That's half of 48, right? So I don't have to divide both. It's not distributing. That's a time sign in between. So you don't, if this was 6 plus 8, yeah, you'd have to divide both things by 2, okay? But here, you divide this whole side by 2, you accomplish that by just dividing that thing in front. And then that would be your 1 over 4p, okay? So if you have a number in front of there, and you have another number there, that's how you get rid of those and get your 1 over 4p business. Okay? All right. So that, I think is one of the biggest things. If we can do that, then I think our makes things a little easier. Okay? Anything else on this front side? So 5's a lot like that. Okay? What was your answer to 5 as far as standard form? It was x plus 8. Yes. 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 I was trying to do that in my head, and I was missing something. And then this is a 3, and then y plus 1 quantity squared, I think is what you should end up with on that one, which is a sideways opening parabola. It would be -8. -1 would be the vertex, right? So -8, -1 would be down here. What's your p end up being? 1/12? P ends up being 1/12. So 1 over 4p would equal 3 over 1. So 12p equals 1, p equals 12. So your focus would be 1/12 this way from -8. So it would be -7 and 11/12. Did I do that right? Comma -1, that'd be your focus. And your directrix would be back here. That would be from -8. It'd be another 12. So that'd be x equals 8 and 1/12. Be your directrix. And your axis of symmetry would go right through there. That'd be y equals -1. Your axis is symmetry. Okay. Now, one thing I haven't made a big deal about on any of these things is the graphing. But I will on the quiz, if I tell you to graph it, let's just do one of these. Let's say, does anybody care 4, 5, 6? You got preference? Any one of those you want to see? Okay, I'll do 5. All right, so I would move the 3 over there. You got y minus 2 squared. The only thing, so the only thing I would ask, the 1 over 4p would be 1. So 4p equals 1, p equals 1/4. Okay, so we've got our 3, 2, 1, 2, 3. So there's our vertex. Now, the only thing I would ask is that you plot the focus and that you plot a couple points just to make sure, that don't just roughly sketch it in there. That's kind of what we've been doing on the homework and stuff, just to kind of get an idea so we can get the directories, things like that. But on the quiz, let's plot a couple points that just, make it look a little better. So, so in other words, on this one, so we got 3, 2. Here, it's going to open to the right. Okay, we know P is 1/4, and so again, it's really small. You can change these units if you want, but if you don't, it's going to be, your focus is going to be there, your directrix is going to be back here, right? Just as long as they're kind of in the right places. But when we go ahead and plot a point, so let's say here X is 3, let's put in a 4 for X, for example. So you put a 4 in for X here, 4 minus 3 is 1, you get Y minus 2 squared. Do the square root of that, you get Y minus 2 equals 1, okay, and then you add 2, you get Y equals 3. So if you go over here to 4, you're going to be at 3, okay? And so at least that gives you kind of a look of where it's going. Even one more point wouldn't hurt, okay? Then you're going to be off the grid probably, right? If you put a 5 in for X, you're going to get a 2 there, okay? Then you square root that. Now you're getting into decimals, square root of 2, and then it gets a little harder. But just try to draw a decent picture on those. Okay, and that's all they really wanted. But when it says graph the equation, let's go ahead and put in the directrix. Let's put a dot in for our focus. Okay, axis of symmetry you don't need to put in. If you do, it would be kind of wrong. But directrix and focus, those are the two really key parts. Because remember, that's part of the definition of the parabola, right? All the points that are equal distant from this line. Put that in blue. Remember the definition of the parabola, all the points that are equidistant from this line and this focus. Okay. All right, how about the back page? Any question on any of those?
Do you want to be those, like 4 through 7?
Anyone?
Yeah.
Okay, so let's just pick number 6 here. And I do have the answer sheet somewhere, so if you really want to double check, I'll have to dig that out here. If you want to double check, just to make sure you're on the right path here. But so 2, 1, and the directrix, that's the more important one to get the sense of where this is going. Y equals -1. So right away, when you see the directrix is Y equals -1, which way is this opening? Up or down, for sure, right? It's got to be an up or down. Okay, then when we see that the focus is at 2, 1, okay, now we know it's opening up, right? And so this is 1 unit, and this is -1. Where does that tell you the vertex has to be? It's got to be halfway in between, right? So if this is the point 2, 1, then the vertex has to be at 2, 0. And of course, that's the key. The vertex is the key to writing the equation, the vertex in P, right? So right away, since we know it's an up one, this is going to be Y minus our Y value of our vertex is 0. And then we're going to have our 1/4P there, and we're going to have X minus 2 squared. So since we know it's an opening up or down one, we know it's got to be the one where X is squared. We've got our vertex 2, 0 in there. And P is what? P is 1. So 1/4P, we just put a 1 right there. So that means there's going to be a 1/4. Okay, so since P is 1, P is this distance, remember, P is this distance right there and there. So once we know that, we just plug that into the 1/4P. And it is opening up, so we make sure it's positive. That's where it gets tricky too. We can easily forget that. If this was opening down, we'd have to stick a negative. We'd have to stick a negative on that. Okay? All right. All right. Well, let's go ahead and get your notes out. All right, so, of course, on your gold sheet, you know, you can look ahead already and see kind of where we're going to end up with this thing. But you know, your ellipse or your oval, a lot of times it's called an oval, but technically, you know, it's an ellipse is what it's called. And it's this shape right here. And so ellipse and circle are very closely related. Okay, their equations are closely related. And you could say that a circle is actually just a special case of an ellipse. Okay, it's an ellipse with, you know, a special property, and that is that the focus and the center and the whole thing is the same. Now we have two foci on an ellipse, so a focus very similar to the idea of what a focus is on a parabola. Now one of the things I did, and we'll see if we get a decent day and I can find the headlight that my wife hid from me. She didn't hide it from me, but we haven't been able to find it. But if we go back to the parabola, this is kind of a cool thing. If you look at an old-fashioned headlamp, and we've got one, or you think of a satellite dish, okay, as a parabolic shape. One of the things we didn't talk a lot about, but when you have a satellite dish, that piece right there, that receiver right there in the middle of the satellite dish, is at the focus. That's where it is. And one of the properties of a parabola is everything that comes in here parallel reflects right to there. In other words, all of those really weak kind of satellite signals all come into the reflective surface of that dish, and they reflect right to there. Now, the calculus connection here has to do with tangent. One of the things we do in calculus, we talk about tangent lines to a curve. And what you have right here is you have congruent angles right there. So that reflection off of that, okay, bounces like so. So those are congruent angles. So all these weak rays come in here, and they're all reflected to there, making a strong signal. Likewise, the old-fashioned, now the newer headlights don't use this because they've got different light that's brighter, and they don't need this. But they were parabolic in shape, and so you could put a pretty small light right here, and all of the rays that normally would scatter off in all directions, all the rays that bounce this way, all are reflected back out of the light. And so we've got a little experiment we can do with that I'll show you. One of these, if we get a halfway decent day sometime. Okay.
75.
Yeah, it's supposed to be decent later this week. So, and if it's sunny, maybe we can do it. Well, first I got to find this reflector thing. So anyway, it's very similar idea here with these foci on the ellipse, okay? And they are symmetrical, so they're equally spaced from the center. They're equally spaced from what we call the vertices of the ellipse, which would be perpendicular to each other going up and down this way, okay? Now, if we look at an example of how we draw ellipse, this is actually the definition. So if you want to write this, well, let's see, let's write down my version. I don't mind, might be a little different. Get that one. Come on. Okay, so here, let's write that down for a definition. An ellipse is a set of all points, or a locus. Remember that word we've used, a locus. Set of all points in a plane, the sum of whose distances from two fixed points, which is our foci, is a constant. Now, similar to our parabola definition. Parabola definition was a set of all points that were equal distant from a fixed point, the focus, and the line, the directrix. Okay? This is the set of all points, the sum of whose distances from two fixed points is a constant. Okay? So in other words, this length and this length added together is the same all the way around the ellipse. So let's say that added up to 10, right? Let's say that this was a length of 4 right here, let's just say this was 4 inches long and this was 6 inches long. Adds up to 10. If you pick another point, say over here, then maybe that's 7 and 3 or whatever. In other words, it's a fixed length, okay? A fixed length all the way around. So what you could do is take a piece of string. Now we're going to just do it kind of electronically up here. So let's say this was a piece of string that we have taped down to the board right here at these 2 spots, okay? And then we were going to take and put our pencil in that piece of string. So this blue is like this piece of string that's 10, whatever, inches, let's say. And we were to grab this and drag it, okay, and go all the way around, right? That would create an ellipse. Okay, so that length of that string is not changing, right? So this plus this is 10, is constant the whole time.
How does the pencil go through the string?
Will it ever catch up?
It's, you can't even see it. We're picking it up and switching it around so fast. That's why this is so much better than actually drawing it. Okay. All right, but that's it. Okay. So as this goes around, right? Yeah, right here you know, pick up your pencil, flip it around. Okay. All right. So some of the terms that you're going to want to know here. So for example, the center, obviously, your foci, F1, F2. This is called, now remember, it's an oval, right? So it's like a stretched out circle. So the stretched out side, the longer part, is called the major axis. You know, in a circle, it's called the diameter because it's the same no matter where you draw it, but that's not true in an ellipse, right? So we call this the major axis, and then we call the shorter one the minor axis, okay? Now, you're going to have ellipses that are the longer horizontally, and then we're also going to have ellipses that are longer vertically, right? And they'll have 2 different equations. They'll be similar, but it'll be much like parabolas. Your parabolas that open this way have one equation. Your parabolas that open horizontally instead of vertically have a different equation. Very similar, but it's a little bit different. And it's going to be the same thing with ellipses. Okay? All right. So major axis, minor axis, and so forth. Okay. Now, let's see. Yeah, I wanted to, no, hang on before we do that. Yeah, no, I do want to show this. Okay, so some of our terms, so let's make it a little wider this way, okay? So this distance, so in your notes here, and again, you can see it on the gold sheet too, this distance from here to the focus is C. Now remember we had P on a parabola. P was that distance from it wasn't the center, it was the vertex to the focus. Okay? We're going to have 3 distances. We're going to call them A, B, and C. Okay? The distance here on your major axis, that's A. So from the center all the way out to your endpoint on your ellipse, that's A. Now A is always going to be the longer. A is always going to be on the major axis. Matter of fact, sometimes A is called, sometimes you'll see A called the semi-major axis. And all that means is half. It's half the major axis. So the major axis is oftentimes called 2A. Okay? So A is half the major axis, or sometimes called the semi-major axis. And then this distance up here is B. Okay, and that's that would be the semi-minor axis. That's the shorter one. So major is for the longer, minor is for the short. Okay? Now, you might even think of that as the long radius and the short radius, but the whole definition of radius is it's the same all the way around the circle, right? And what would happen if this becomes a circle? Well, A and B would be the same, right? And the focus actually would disappear into the center. The focus would actually become, so the more this becomes like a circle, the closer the focus gets to the center. Okay, the more it's like a circle, the closer the focus is to the center. So if I take this off here, so if I drag this point, right? So you get really close to being a circle, the focus get in here. Now, all of a sudden you turn it this way. Now look where the focus goes. Now we'll draw this picture in a second. But now when the longer or the major axis is up and down, now your focus shift to being along here. So another thing you could write down here is the focus is always on, okay? The focus is on the major axis. Actually, that should probably be foci. Foci. My grammar is really good. Foci are on the major axis, right? So if you have an up and down, a vertical ellipse, then you have foci on there. Okay, so like we drew, we said A is on the major, A is this length, and C is there. A and C are always going to be on the same line, the same axis. A and C, the focus is always on the longer one, and remember we said A is always the longer one. Okay, and I think that says that on that gold sheet as well, that A is always larger than B in an ellipse. A is always larger than B. Okay? All right. So let's take a look at an equation. All right? Here's an example equation. Here's an example equation of an ellipse. Now, you notice that it's got both an x squared and a y squared. Parabola is the only conic section that has one squared and the other not. Circle, they're both squared. Ellipse are both squared. Hyperbola, they're both squared. Okay? So here's an example of an ellipse equation. Now, it's not in its standard form, and we're going to get it into its standard form here in a minute. Okay? So if we go and look at an ellipse. So right now I've got a circle. Okay? Now, you don't need to write any of this part down right now. But this would be a circle equation. So if we were going to get this would be a good review for the quiz. So if we wanted to get this equation into standard form, right here, of a circle, what would we do? Divide everything by 4. I agree. You'd have x squared plus y squared minus 16 equals 0. Then what? Add the 16 over. Because standard form of a circle is x minus h squared plus y minus k squared, all equal to r squared, right? So that would be our standard form. So 0, 0 would be our center, radius 4, radius 4, radius 4, all the way along. Okay? All right. Now, what do you suppose has to be true about these coefficients right here for a circle? They have to be what? The same, right? If you're going to have a circle, the x squared coefficient, the y squared coefficient have to be the same. Okay? Because when you divide them out, you want a 1 in front of the x squared and the y squared. You got to have a 1 in front of the x squared and the y squared, or it's not going to make a circle. So, look what happens when you have them different. Sure enough, it looks very much like the same equation. It's just that the x squared and y squared coefficients are different. The graph ends up being this. Okay? Now, what is our standard form going to look like? Well, the whole point of a standard form is for it to be useful. The reason this is useful is because this gives us our vertex, and this helps get our focus and our directrix, and we can get the most important information out of that. The circle standard form is the way it is because it gives us the center and the radius. If we know those things, we know what we need. Okay? So what are we going to do with this? Well, what we're going to do with this is we're going to add the 4 over. So if you want to write this down, you can. We're not going to have to, well, we will have to do this some, I guess. So it would be good to do this. we're going to get this over here because this is what you do with the circle, right? Remember, an ellipse and a circle are very closely related. Now, here's where it gets a little different though. You might say, well, we would divide by 4, and you would actually be right that we're going to divide by 4, but not because of this 4. A lot of you would probably be thinking divide by 4 because of this 4. Actually, we're going to divide by 4 because of that 4 over there. It turns out for an ellipse equation, we want a 1 to be over on the other side every time. If we have a 1 over there every time, we will have a lot of important information about our ellipse. So we're going to divide by 4. Now you might say that this would be 1/4, and normally I would rather write 1/4 than this, but it turns out in the ellipse equation, it's going to be better if we have a divide like that. Okay? Plus, what's this one going to be? Y squared, but you know what we're going to do? We're going to put a 1 under there, even though it seems kind of unnecessary, we're going to actually put a 1 under there. And then this side is going to be 1. That is going to be considered the standard form for this particular ellipse. Okay? Now, you might, okay, so the question may come up, why does that give us important information? What about that gives us important information?
Can you get like your A and B?
You can get your A and B, but before that even, what about the center? What do you think your center is? 0 and 0. Turns out our standard form, which we're going to rewrite in a minute here so you don't have to worry about it, it turns out that it's going to be very similar to like a circle, that our center is going to be these numbers in here. So we're going to be completing the square because we're going to want to get those numbers written that way. But what about these things right here? Well, let's go look at it. We got a 4 and a 1. Let's go back to our picture. Charlie, you were talking about the A and the B. What do you notice that distance is right there? That's 2. What is that distance right there? That distance is 1. This is the long axis, so that would be A, right? So in this ellipse, the A is 2, and the B is 1, correct? Okay? Now, and the A is horizontal, just like the X is horizontal, right? Okay, let's go back to our equation. So we said the A was 2 and the B was 1. How does that play into this right here? Oh, that seems to be A squared. And this seems to be B squared. And it turns out that that is exactly right. Okay? So, here you go. This is our first standard form that we have for an ellipse. Now, I might have that on another page here. I do. But anyway, that is the standard form for an ellipse that is horizontal. Now, let's think of all the things we've talked about so far, because it's a lot. The A is the longest, we said. Right? Notice that the longest one here was under the X. That tells you that your long radius, your long your major axis is going to be along the X. It's going to be horizontal. So whichever one is the bigger number down here is the A. Well, it's A squared. So we know this one's A squared. The bigger one is always the A squared. Whichever one it's under tells you if it's going to be horizontal or vertical. So the biggest one under the X, horizontal. Bigger one under the Y is vertical. Now I've got an example of that here. So here, notice I put the 4 on this one. Now look what would happen if we take this and we add, let me see, wait a minute, do I have that? I think I might have that here. Yeah, so let's say we had this one, okay? We'll look at the picture of it in a minute. Okay, so how are we going to get this one in standard form? We're going to add the 9 over. And then we're going to divide everything by what? 9. That's right. We're going to divide everything by 9. Now, that's going to give us something we don't really like on that first one, which we're going to fix here in a minute. but it gives us the 1 that we want over there. That's the key. This is okay. We don't want that 4 to be there. Now, we can think of that as 4/9 x squared, right? Right? Everybody agree that that's the same as that? Well, timesing something by 4/9 is the same as dividing by 9/4. Let me say that again. Timesing by 4/9 is the same as dividing by 9/4. So what we're going to do is we're going to write that as x squared over 9/4. We're going to write this as y squared over 9 and then equals 1. Okay, everybody with me on that? So we got 4/9 here. We're going to flip that and put it on the bottom. It's kind of like 2 wrongs make a right. It's like those cancel each other out. By flipping it and then putting it on the bottom, it's like we haven't really changed anything. Or think of it as timesing by 4/9 is the same as dividing by 9/4. So what does that tell you your A must be? Which one of these is bigger? The 9 is. So the A must be 3. Remember, this underneath here is A squared and B squared. So the A must be 3 and the B must be 3 halves, right? The square root of 9/4 would be 3 halves. Now, since the A, the longer one is under the Y, that means we're going to have a ellipse that goes like this. We're going to go 3 up here on the Y, and we're going to go 1.5 that way on the X. That's your A and your B. The longer one is under the Y, so that tells you it's going to be that direction. And again, if you look at this one graphed, sure enough, look what we got. I said that it was going to go up 1, 2, 3, and it was going to go over 1.5, which is what it is, what the A and the B are. So again, the work we're going to be doing is getting these things into standard form, okay? Because once we have them in that, it tells us really everything we need to know. Our center, it tells us how far to go horizontally, how far to go vertically, and then we just draw. Okay, now we're going to get into some other, we're going to get into some other stuff after lunch with the focus. How does the focus come into there? Because remember on my picture earlier, I showed you that C was the distance from the center to the focus. So how do we find C? Where does that come in? Okay, and we'll get into that here a little bit. Okay, let me see what my next example was. Oh, yeah, we'll get into that. Okay, so we already talked about that. We talked about A being the semi-major and B being the semi-minor. So the major axis would be 2A. Obviously, the whole axis here would be 2A. The whole minor axis would be 2B. Yeah, we'll get into that later. Okay, so let's finish up a little bit here with the ellipses. So tomorrow we'll do the quiz before lunch, probably have some work time, maybe some IXL work time after the quiz. And then we'll see if everybody's done with the quiz in plenty of time. We may talk about just a little more on the ellipses, and then so you have more work time after. We'll just kind of play that by ear and see how it goes. So the next quiz after that, because we have ellipses and hyperbolas to talk about, I don't think we'll get through all of that by the end of the week. So probably next week. And then that's it on this chapter, and then we'll we'll do a test, I guess you call it, a quiz over all of the different things, right? So this will not be tomorrow. No, tomorrow is just circles and parabolas. Just circles and parabolas tomorrow. Okay, so let's just finish up here with what we were talking about here on the phone. Now remember, keep in mind that x and y, so in our equation, x and y are always points on the figure. So x and y are points on the ellipse. H and K is the center, right? And then the C is how we get, so I'm going to talk about the C here, the last thing. So we were talking about our equations, and you kind of wrote them down already, so I wouldn't worry too much about it, but we got this. Now, notice there is a plus sign in between here. So on your gold sheet, I think that this one is flipped. So they always have the A first, the bigger one first. But all that matters is which one the bigger one is under. If the bigger one's under the X, then it's going to be horizontal. The A is the bigger one, and that's going to go this direction. If the bigger one is under the Y, then it's going to go up and down along the Y for your A. Okay, and the foci are always on the same line as the A. Okay, but since it's a plus sign, it doesn't matter. These two can be flipped around. It doesn't matter. Okay, so I think on the gold sheet it's written so the A is always first. I wrote it up here so the X was always first. Doesn't matter. Now, when we get into hyperbolas, it's a minus sign here. Well, then it does matter. When you're subtracting, the order does matter. And so in that case, the A is always the one that's first. And so I think whoever wrote up this sheet of formulas thought they'd stay consistent with that. So, but just understand, when there's a plus sign, these two can be flipped around. What matters is the bigger one is the A, and the bigger one is whichever it's under, the X or the Y determines which direction it goes. Okay, so A is always bigger than B, and C is the distance from the center to the focus. C is the distance from the center to the focus, much like the P, I guess you might think of, was on the parabola. Well, here's the connection. Once you know the A and the B, C squared is always A squared minus B squared. Okay? C squared is equal to A squared minus B squared. All right? Looks like the Pythagorean theorem. It's not. Okay? So it's got a subtract sign in it and so forth. But, and again, it gets confusing to remember all that. That's why I'm going to go ahead and let you have the gold sheet there for that. So once you know what A squared and B squared are from your equation, then you can figure out what C is. It's usually a square root. Not always, but a lot of times it's a square root. And we'll usually just leave it in radical form when we write it. But we'll get into more of that tomorrow in the next several days. But we just want to start with some basic ones for right now. This other part, this eccentricity, we're going to wait and talk about tomorrow. I'm not sure it comes up in any of the homework, so we won't worry about it. Okay, so let's do a couple of problems together just to look at what some of these might look like. So this is number 11 in the book. So we're going to do a few together, then I'll give you a few to do for homework. So what would be the equation of this? Well, what would you start at? What would you look at first? Center. I think center is a good place to start, and it's at 0, 0. So that tells you you're going to have just plain old x squared and plain old y squared. And of course, you know in an ellipse you're always going to have a 1 over there. Right? So your center is going to be inside of here, 0, 0, and you're going to have a 1 here. Then it's just a matter of what's A and what's B. And which one does it go under? So what is A? Well, okay, I know what you're thinking, but think of what my question was. What is A? A is 4. Okay? The A is the longer one, and so that would be that right there. That would be 4. So that means what goes under, which ones it go under? It's got to go under the Y, because it's up and down, right? And what goes under there? That's the 16, right? So that's A squared, and so that's 16. And what's B? 2. So under here is 4. Again, since it goes horizontally, that goes under the X. It's really that easy. Just can't mix up the A, the B, and those things. Okay? All right? You guys try this one. Okay, the center's not given. This 0, -1 clearly is that point there. So you guys try that one. Okay, there it is, I think. center is right here at 2, -1. So 2, -1. So that means the 2's got to be in with the x, -1 in here. And A is the long one is 2, and it's horizontal, so it's got to go into the x. 2 squared is 4. Okay, not too bad. All right, graph. Just do a quick sketch of that one. Okay? Don't feel bad if yours isn't as good as mine. Actually, if yours is worse than mine, then you probably should feel bad. But just label things appropriately, right? So you're going to go 5 on the x, you're going to 4 up and down on the y. Okay? There you go. Okay, try that one. Sketch that one real quick. If you want to look, I've got it up there. Otherwise, finish up. All right, so -3, 2. Again, things start by going to the center. The bigger one is under the y, so that's going to be 4 up and down. So it's just, I mean, if you just sketch it, it's going to be obvious it's going to go up more up and down. But it's fairly circular because the 12 and the 16 are pretty close to the same thing, right? So you're going up and down about the same that you're going horizontally. So it's pretty close to circular. Now square root of 12 is what, about 3.5, roughly, a little less. Okay, and so you can kind of estimate that. Now we'll get into this tomorrow and the next day. Like if they may ask for you to write down the coordinates of the center, the coordinates of the foci, the coordinates of the endpoints of the major and minor axis. So they may want you to write the coordinates of this. This would be the minor axis here. So the way we would write that, this is square root of 12 is how far we went this way, right? Now I'm fine with you leaving that square root of 12. You could break that up into 4 and 3, and that'd be 2 root 3. You could do that, but you don't have to. And so how would we write this? We would write this point right here. Its x-coordinate would be -3 plus square root of 12. Okay, if I tell you to leave it in exact form or radical form, then we would just do that. And then the y value, of course, is the same. That would just be 2. And then this one over here would be -3 minus square root of 12, and then 2. Okay, so from -3, we subtract square root of 12, okay, which is what the b would be here. And then we would write them like that. So we'll get into something like that and talk about those later on. Okay, last one. Last one. So this is where we're going to get in. Let's just do this one together. So this is where we're going to get into the putting it into standard form. Now, I think with ellipses, it works better when we complete the square to do the factoring out thing as opposed to the dividing thing, because it just gets a little messier, I think, with that. Now, if you want to try it and think, hey, no, it makes sense to me, then we can certainly talk about it. But what we're going to do is we're going to start by grouping our x terms. Okay, so I want to get the x terms together, kind of leave myself a gap, then put my y terms, leave kind of a gap, and then move that 36 probably over to the other side. Okay, so we're going to have to be completing the square on both of them. Remember, an ellipse, just like a circle, has x squared and y squared in it. Okay, so on this one, we're going to want to take out that 9, and we're going to have x squared plus 4x plus a gap. Here we're going to want to take out that 4, and we're going to have y squared minus 6y plus a gap. And then, of course, we have our -36 over there. Okay, now, it turns out, once we have done that, okay, at this point, we actually could divide. And it's usually going to divide, it's usually, not always, but usually going to work pretty nice. Because what can I divide by right now? I could divide by 36, right? Actually, I want to divide by 36 because I want a 1 over there. Now, you might think better do negative. Well, no, don't worry about the negative, because then that's going to turn these negative. We don't want that to happen. What will happen is once we fill in our blanks, that'll take care of that negative over there. Okay? So we could do this. We could do this now. Matter of fact, this probably would be a good time to do that. Okay? I think before wouldn't have been a good time. If we divided everything by 36, it wasn't going to work very nice right here with that 24. It would have worked good with these other things, but I think right now is maybe the time to do that. So what are you going to get here? If you divide everything by 36, what's going to happen to this 9? What will you have? You'll have what underneath it? It's a 4, right? A 1/4, right? Does that make sense? Does that make sense to do that right now? So what we're going to have is we're going to have our x squared plus our 4x plus our blank, and then underneath we're going to have a 4, right? Because basically what you're saying, let me put it in a different color here. What you're saying is let's divide this by 36, let's divide this by 36, and let's divide this by 36 is what we're saying. Okay? Well, this 9 is going to cancel that 36 and make a 4. That's what's happening here. Okay? And what's going to happen here? 4 is going to cancel that and make a 9. So we're going to have our y squared minus 6y plus our blank, right? And then we're going to have a 9 underneath. And then over here we're going to have a -1. Now we can complete our square. So what are we going to want here? A +4. We're going to want a +4 over here. Okay, what about here? Yeah, this isn't going to work. This isn't going to work as good as I thought. Why isn't this going to work? did I really add a 4 onto this side? Did I really add a 4 to this left side? I did. I added a 1. I really added a 1. So I thought that was going to make this easier. It's not. It's going to work fine. Why did I add a 1? Because I added a 4 over 4 is what I added. And I added a 9 over 9, which is another 1. So that's fine. You could do that. But that's no different than if we would have just not divided this at all. So, okay, so let me come back to this. What goes in here? A plus 4, right? Now, what did we really add to this side? What did we really just add there? A 36, right? We added a 4 times a 9 is 36. Okay? So dividing that would have been fine. What's that?
Oh, just
Okay. And what are we adding right here? 9, which is a 36, right? And so what do we have now? We have a 9, and we have an x plus 2 squared, and then we have a 4, right? These aren't crossed out anymore. And a y minus 3 squared, and then what do we have on the right side? 36. Now what are we going to divide by? 36. So now when we divide by 36, right, what do we get right here? X plus 2 squared over 4. What do we get right here? We get y minus 3 squared over 9, and over here we get 1. Now, that is the same thing we were getting before, and I'm not, this just looks more familiar to what I was doing earlier. What we did when we divided that 36 was fine. It's just that when I did the plus 4 here, when I first wrote my plus 4 on that side, that was wrong, right? Because if you remember what we had over here, we had -1, then we had a 4, and then we had a 9. Well, that adds up to 12. That gives us a 12 over there, and that's not what we wanted. We wanted to end up with a 1. So we had to know what we added that 4 before, we were really adding a 4 over 4, which is a 1. Just like here, when we add this 4, we're really adding a 4 times 9, which is a 36. So it's really the same. It's really no easier one way or the other, right? You just got to remember that when you do this, completing the square, and you add in this 4, you're not really just adding a 4, okay? So if you want to do the divide first, like we started to go down that road, that would have worked. It was fine. But I think this keeps it a little more like what we've talked about before, is the only reason I want to go back to it that way. And then once you get that done, and you have these numbers out in front, then you divide by whatever's over there so you can get your 1. Okay? Well, that's the thing we're going to have to spend most of our time practicing and working on. Okay, so here's a handful of problems. Most of them are a little easier type, or several of them are kind of easier types like we had done the first part, and there's a few at the end where you're practicing the completing the square thing that we were just doing. Okay?
How do you find foci?
That's the C. That's the C. Okay? So that's the C squared equals A squared minus B. So if they ask you for the foci, yeah, so if we take that one we just did, hang on, I'll go back to the assignment if you did the original. Okay, so yeah, so if you take this problem right here, this would be your A squared, right? This is your B squared. So that tells you that C squared is 9 minus 4, C squared is 5, C would equal square root of 5, right? So now, this particular ellipse is going to go up and down like so, right? And it's going to go 3 that way and 3 that way. Now, I'm not drawing this to scale. Okay? Okay, so this is going to be 3 up and down on the y, and it's going to go 2 this way, right? So then the question is, where are the foci, right? So you're going to add square root of 5 onto whatever this y coordinate is here, right? You're going to add square root of 5 on that direction, and you're going to take away square root of 5 this direction. So what is our center here? Our center is -2, 3, right? So what would this foci coordinate be right here? -2, and it'd be 3 plus square root of 5. That would be that foci right there, because C is gotten by using this equation. And so whatever this y coordinate is, we add root 5, take away root 5 to the y coordinate. X coordinate stays the same. Okay? On the ones, on a few of those homework problems, it says find the eccentricity. Don't worry about it. I mean, it's on there. It's just C divided by A. I mean, we're going to talk about what that really means, but it's just C divided by A. So, in this one, it'd just be square root of 5 over 3.
Why do you do C squared equals A minus B?
No, remember, this down here is A squared.
Oh, yeah.
Right, A is 3 on this one, and B is 2, right? Yeah, so these numbers are already squared. Yep, this is A squared and this is B squared, so that, yep.
I just start looking at this now.
Oh, and then go into Bearcat time? Yeah, grab your calculator. Let's, well, you can bring yours. You can bring your slide with you. Yeah.
So,
We asked for the radius.
if it's a circle, then you get radius. No. You don't define a radius if it's not a circle, right?
Right. Yeah, on the directions it talks about a radius. Well, every once in a while they mix in a circle on some of those. So if it's a circle, you'll have a radius, you won't have foci, right? You'll just have a center and a radius. If it's an ellipse, you'll have a center, you'll have foci. The vertices are considered the ends of the major axis. Okay, so if you look at the definitions, yeah, the major axis, those endpoints are also called the vertices. So when it says the vertices of the ellipse, it'd be these two here. Okay. Okay, who else thought they were going to be gone tomorrow and need to make up the quiz some other time? So Noah, you told me, right? And Lucas, you're coming tomorrow. Okay, Corbin, when are you going to do it?
I do it tomorrow morning.
Okay. Got you down. I'd say, half hour, 45 minutes if you are concerned about having enough time. So, yeah, by 7:15 you should have plenty of time. Who else was going to be gone tomorrow? Kale, when you do it? Tomorrow morning? Okay.
Look at me.
Are you on 37? Okay. 5. That's what I just
I guess you. Well, you find the radius. You're not gonna.
One sec.